Hey everyone. Uh, Good afternoon for those who are on the same time zone that I am. Good evening, depending on where you are. Welcome to another InduSoft webinar. Today we're going to be talking about integrating Beckhoff devices running TwinCAT with InduSoft Web Studio applications. So here's the agenda for today. I am Andre Bastos, and I'm going to give you first a brief company overview, and then going to talk a little bit about our driver architectures and the other connectivity options that you have on the product. We're going to go and look how our TwinCAT driver works, the one based on Beckhoff's ADS. I'm going to show a little bit about OPC UA and the option that we have with the tag integration, sharing tags directly with the TwinCAT project. We're going to go through a troubleshooting session and open to Q&A. So you can put your questions, and we're going to answer at the best of our knowledge. We're going to be joined today by a very special guest, Mr. Rich Lester. He works for Beckhoff, and he's going to give you guys a product overview. He's going to talk a little bit about TwinCAT 3 and how you migrate from TwinCAT 2 to TwinCAT 3. Explain what the ADS is, and mention some things about the OPC UA, which is a very robust technology endorsed by both InduSoft and Beckhoff, to the point that Beckhoff, actually OPC Foundation Europe, the president of the OPC Foundation Europe is actually someone from Beckhoff, Mr. Stefan Hope. So we're starting with a company overview about InduSoft. So we were established in 1997, and we've been, since September 2013, we are part of the Invensys group. We were pioneers in the industry as being the first HMI SCADA package to have a complete solution for Windows CE, and that dates back to Windows CE 1.0. We have a web solution and integration for any HMI size, and that again includes Windows CE. We hold a patent for database connectivity that allows your runtime that is running let's say on a Beckhoff CX device, CX9000, acquiring data and saving this data directly to a relational database such as Oracle, such as SQL Server. So we have the patent that allows you to establish this connectivity. And we also already support multi-touch and HTML5 integration. And that means that the new Beckhoff panels with multi-touch, you can take advantage of InduSoft features on that panel as well. And I'm going to be demonstrating today a video of the PAC Expo that is happening right now in Las Vegas, where you have on Beckhoff booth a touchscreen, a multi-touch screen panel running an InduSoft demo, and you can see some of the things that you can do with the multi-touch. A little bit about the certifications. We are OPC Foundation members. We are certified by the OPC Foundation for compliance. We are at ISO 9001 company, Microsoft Gold Partner for quite a while now, and certified also by AT&T and Motorola. And here are some of the awards that we've been getting throughout the years. And as you can see, 2013, we got 3 awards from the Control Engineering magazine. What's very interesting about this award is because those awards are voted by the readers, so people that actually know what they're doing, and they vote on InduSoft for 3 awards this year. And as you can see, we have a list of Frost & Sullivan awards as well. So a little bit about the connectivity options that you have with InduSoft Web Studio. So I'm going to start here on this area where we start talking about first the OPC options. So we have all the flavors of OPC. So OPC Classic, used to be OPC DA. We have the Unified Architecture client as well. UA, we have OPC.NET 3 and XML. So we have all the OPC options as part of the InduSoft offering. And also, as part of the package, you also have over 240 proprietary communication drivers. That means that you can use InduSoft, not necessarily you need to have an OPC server to use InduSoft to talk to your device, to talk to your PLC. We have drivers for the most non-brands out there. So we have for TwinCAT that we're gonna demonstrate today, but we have also for Allen Bradley, Siemens, Modbus, Omron, GE, and even the maybe less non-PLCs, we may have a driver for those as well. Okay, and if we don't have the driver, you can get one of our toolkits and write a driver yourself. So we are open architecture. We sell APIs for you to integrate with our text database or to write your own communication drivers. Or we have also the connectivity to databases using ADO and OLEDB and the legacy DDE as well as XML communications or communications using the XML format, if I may call that. We do have TCP/IP communications among applications, so I can talk an InduSoft application, one computer with another computer, but also not only with InduSoft, we can also communicate with InTouch and even with iFix from Insolution/GE. And everything on Web Studio is web ready. So using Internet Explorer, you can control your entire application from a remote computer using only the browser, or in our mobile access solution using HTML5 can be on any tablet, that can be Android, that can be iOS, that can be Windows Phone, with still some limitations on what you can put on the screen, but you can create entire functional applications with the features that we currently have. Okay, so a little bit about the architecture where the driver goes on InduSoft Web Studio. So first have the products with the InduSoft Web Studio core process. And the heart of the product is actually the tags database. So the tags database receives the data from, let's say, the driver, the OPC, or any other test that may change the value of one tag. It processes and sends the data out to all the other tasks. So a typical application would be you have a device. Let's say I'm putting here as a process controller. It could be a PLC, could be a CNC, could be just a multi-loop temperature controller, stuff like this. You communicate with that through whatever communication channel, Ethernet or serial. The information gets to the communication driver module, and the communication driver module is going to feed the text database. And from there, through TCP/IP, that information is going to be sent to a local viewer, to a remote secure viewer, or to a web thin client. Okay, that's running on a browser or SMA or any other way that you have to visualize. So basically, the communication driver is one of the tasks. If you're talking about OPC, here you have our OPC client talking to a server, which is pretty much what you had here. So if you talk about OPC specifically, you have the device on this right corner here. The OPC talks to the device using whatever proprietary protocol that device speaks. Through OPC communication, our client module is going to go get the information from the server and then feed the text database. From that, you get to the screen. And again, here are the list of the OPC options that you have with InduSoft Web Studio as part of our offering. So I'm going to invite now our very special guest, Mr. Rich Lester. He's going to give us a presentation about the Beckhoff products and TwinCAT, ADS, and a little bit about OPC UA. So I'm going to stop sharing my desktop here.
Can you hear me okay?
Yes, we can. Go ahead.
Excellent. Well, thank you, everybody, for joining in. My name is Rich Lester. I'm an applications engineer for Beckhoff Automation. I am in southern Texas, not too far from the InduSoft office. We have people all over the world and the United States. We're going to talk a little bit today about our hardware and software solutions and how we integrate with InduSoft. Andre will be covering the majority of that. I'm going to discuss a little bit about the Beckhoff offering. We are a complete automation solution company, so we have got the industrial PCs, PLC software, I/O for distributed I/O, and then motion with drives and motors. You can see we've got offices pretty much all over the world. Our headquarters in the United States is up in Minneapolis. And in the States, we've got a few remote office locations. There's a few more that don't show up, and those are application engineers that pretty much work out of their house, like myself. So it all started back about 1986 with a more of a simple industrial PC, and as time goes on, we started to add in some I/O, more software capability, and then in '96 came out with TwinCAT, which is our PLC editor, and added in EtherCAT I/O, some XFC, and then just recently we've released TwinCAT 3, which has some improvements and capability over TwinCAT 2. In TwinCAT 2, the system can handle I/O, PLC control. The motion is incorporated with that. We can also do interpolated motion and CNC control for high interpolation. And also we have connectivity possibilities to talk to other field bus devices, such as Profibus, DeviceNet, CANopen, Ethernet IP, among a few others. Our product offering is pretty much performance-based. We start off with the lower end with our BC controls, which is just a TLC controller. There's no operating system like Windows installed. The BX has a little bit higher capability. Then we get into our CX product line, which is our embedded PCs. And then our higher end, we're looking at panel PCs and control cabinet computers. TwinCAT software runs in Windows. We are a Windows partner. We have a real-time kernel that runs parallel to Windows. So that's where all of our real-time communication happens. We have many PC platforms, as we already discussed. Our main PLC editor is based on PLC Open. We are also a OPC Foundation member. We do run on pretty much every version of Windows out there, from Windows CE to the older style Windows NT. Recently, XP Embedded, and Windows 7. It does run in Windows 8 as well, although we do not offer that in our products at this point. But TwinCAT does run in Windows 7. Our main programming language, like I said, is based on PLC Open. This is the IEC 61131-3 editor, both second and third edition. TwinCAT 2 is the second edition, TwinCAT 3 is our third edition. And look at TwinCAT connectivity. Everything we do as far as communication, under the hood, if you will, is all based on this ADS, this Automation Device Specification. This is not a Beckhoff invented communication protocol, but it's something that we do use. So under the hood, regardless what language we're actually talking, what field bus we're actually talking, when it comes back to the PC, everything's done over ADS. So you see in the diagram here, ADS is the main hub of the system. It's basically an ADS router that talks out to all the peripheral devices. And we do have the, basically we have drivers and also, let's say, example codes on how to work with this in, .NET or Java. There's several other languages to work with this. TwinCAT 3 brings pretty much what TwinCAT can do, plus some extras. One of the extra things we can do in here is with our C code, either C#, C++. We can add this into Visual Studio, so you can see code for other parts of the machine simultaneously. Also, we get into Simulink and MATLAB. These are additions that TwinCAT 3 can handle. So those are some of the new features TwinCAT 3 gets into. One of the nice things is that TwinCAT 3 is used inside the Visual Studio shell. So it's a little bit different environment than what you're used to with TwinCAT 2, but it does bring a lot of extra capability. One of the things with TwinCAT 3 that we kind of push a lot when we talk is the ability to do all these different tasks on one PC, one CPU. So instead of having a dedicated CPU just for motion, one just for HMI, one just for PLC code, we can do all these in one PC and really utilize the processor that's on the PC. With TwinCAT 3, we have a engineering architecture where you would basically develop all of your code, and then we have a runtime, which is a much minimized sized real-time kernel that would go on your target device, so it doesn't take up as much space on the PC or on the CF card or hard drive. Talked a little bit about some of the benefits. We are in Visual Studio. We talked about incorporating C and C++ into the programming languages. Options here for MATLAB and Simulink. One of the big things is we're now able to run a real-time system on a 64-bit operating system and also utilize multi-core processors. And the migration of TwinCAT 2 to TwinCAT 3 is fairly easy. Your existing projects can be imported directly into TwinCAT 3 without having you to retype all of your code. On the multi-core support, basically now assign tasks to a core. So on a 4-core system, we could run one just to run your HMI and PLC, one that would be dedicated just to motion. Also, if you're doing the C++ code or any Windows application code, you can run those on a dedicated core. And then you can assign these out to however many cores you have. This is one of the really nice things in TwinCAT 3. You can really utilize the entire processor. And again, as you see, our ADS router here is the under-the-hood language as we talk to all these different devices. It's really the core of how everything in TwinCAT works. And then with TwinCAT 3 incorporated into Visual Studio, you can see we've got several different languages to choose from. Very similar to TwinCAT 2, all those same 6 languages, and then also the ability to add in your C and C# directly into the project. And so the feel and look of it's a little bit different there. As far as PC hardware goes, we do industrial PCs, embedded PCs, control panels, panel PCs. There's quite a few offerings. These would be the things that relate to our relationship with InduSoft, with the HMIs and the control panels here. This is a small sample of the products that we offer, from the cabinet PCs you see on the left of the screen to the panel PCs and just control panels on the right. With all of our product offerings, there basically is the correct PC for the individual application. Some people don't need the best, greatest, fastest thing out there, and it's pretty much price per performance. So the more you need to do, the more capability you need. We step up in performance on the PC, and of course, price comes accordingly. So we have panel PCs, which would be a PC and an HMI screen all in one. These control cabinet PCs, and then our control panels as well. And then we have a full line of embedded PCs. These are generally our CX products, and they're all DIN rail mount. You can get a variety of performance out of them, along with data storage. And as you can see, all the I/O would be directly attached to the PC, and then you can also extend off of this for distributed I/O. And then this is a little bit of range of our different embedded systems. Starting out our lower end, if you will, our CX8000 is going to have a 400 megahertz processor, which in the automation world is actually still fairly fast. This does have a Windows CE operating system on it. And then as we jump up, we have a little bit faster CPU usage. With our 9020, we're now at 1 gigahertz on an ARM processor. Still very low price, high performance systems. And then as we go up to our newer product line, our CX2000, which can have a i7 quad core processor in it. So very, very scalable product range. And our panel PCs, or as it says here, all-in-one, is basically a touch panel with a CPU attached to the backside. We offer this in a IP20 and also IP65 offering. Several ranges here. So as we go through, the panel PCs, just like all of our other stuff, have a wide range of processor power and then also size. You can get down to a stainless system. All kinds of options on these. Again, very application dependent. Then we get into some of our multi-touch systems, which are newer for this last year. The display format can be the older style with the 4:3 ratio. And now we also have the widescreen, which is becoming very popular, and then the capability of having multi-touch. You can see in this product range, there's also several processors capable. Here's one of our stainless steel panels. You can get a customized front panel here, whether you need an e-stop, a couple of push buttons. If you need to customize the panel with graphics, that can be done as well. And our control panel, our CP69 series, which is shown in the upper left here, is one of our more popular series. As we get into full-size computers, which was shown on the bottom right there, where you need, full-size PCI or ISA card slots, we offer those as well. And as you can see here, they're also very configurable, even down to more of an old-school PS2 keyboard capability. We still offer that for those who need it. And then our C69 series, these are pretty much they're workhorse. One of my favorite products that we offer. Their scalability range is quite large. You can get the dual DVI ports. You can get field bus connectors right on the front, whether you want CF card or hard drive. It's very customizable for your application needs. And then our control panels, which is not necessarily with a processor. These can be pole mounted in an IP65 type setting. As we get through here, we have our Ethernet panels if you're going to run a more of a simple program or just an HMI. So it's more of a dedicated purpose. And then the capability of having multiple systems or multiple HMIs on one system. And we will also get into our CP-Link systems, which is coming up. Again, we get to our CP29, our multi-touch systems here. You can see some of the ranges and sizes. And then we get into the actual multi-touch function. And we have a video that was taken, I believe, yesterday at our PAC Expo that's going on in Las Vegas right now. We'll go through this a little bit here. Kind of a short video, but as you watch this, you'll see that this is an InduSoft application that's running. And right here we're showing you can have up to 5 pointers at one time, if you will. So the whole multi-touch system is very new in the automation world. With this, you can pan in, zoom in, rotate. There's definitely several reasons that somebody would want this. And also these newer multi-touch panels are using a glass front instead of plastic, so they're much more resistant to scratching. And here in a second there'll be a little video you'll see here where you can rotate the dial, and then it'll basically adjust the speed here for the temperature set point, and then you can get some fun stuff like that. So we offer these both in panel PC or just a panel, and then also if you need an IP65 rating, we offer that as well. These are also very customizable. You can see we have e-stop, push buttons, number of push button capabilities, and then if you need graphics, on the screen, those are very customizable as well. There's just a couple offerings here. We offer this in a stainless steel option as well. And then you can see some of the more customized things some of our customers have done to their panels. So what you see in the catalog is not all that's there. We definitely do some customized panels. There's a few more there. And then CP-Link 3 is a new system here. we can have multiple panels, multiple PCs tied together, and this is a very new feature where we can actually have one cable from the PC to the panel, where most systems would take three, where you have power, USB, and DVI all separate. This new CP-Link 3 can actually be done all in one cable, and the length of this is, I'm not sure what the actual spec on it is, but it's very long. So this can be done in a single cable situation, or actually in a multi-cable where you pull the power out separately. So here's a PC with multiple panels on it. This would all be a CP-Link 3 application. And whether it be multi-desktop or extended desktop, you can handle that as well. So those are some of the primary product offerings that we have. We didn't really discuss I/O, and we really didn't discuss motion as far as motors and drives go. But this is really more related directly to how we interact with InduSoft. So I would like to, again, thank you guys for joining the WebEx, and thank InduSoft for allowing us to join in and present on this. And I will hand it back to Andre.
All right, Rich. So thank you very much. It was very interesting. And, some of those products, I'm a big fan of the Beckhoff solution. This CP-Link is very interesting, like one cable for everything. And you guys saw that they have several different kind of controllers. So they go from a lower range, a 400 megahertz ARM-based processor, all the way to quad-core. So when you guys use that, keep in mind that the lower the processor, the lower the power that you're going to have. And so you cannot sometimes think that you can run a project with, let's say, 50 screens and talking to you 2,000 tags on the lowest end processor. That would be a little too much. So you always should size your processor according to your application, because I don't know if you guys got that, but you can run both InduSoft and TwinCAT on the same CPU. And use, let's say, a remote thin client, could be a secure viewer, could be a web thin client, to be the actual visualization resource for you. So if you're going to run both on the same controller, just keep in mind when you are choosing the controller that you're going to be running an HMI software on it as well. So that's going to help you deciding what's the ideal controller for your application. So again, thank you very much, Rich. It was very interesting. And now you're going to go to the part where we're going to start actually communicating with some TwinCAT. You have several different architectures here. I want to show you guys a little bit about TwinCAT 2 and TwinCAT 3, how we interact in the InduSoft Web Studio with those guys, okay? So I'm going to start talking a little bit about the configuration for our built-in driver called TWCAT, which is based on the ADS from Beckhoff. So if you look on this slide here that I copied from the Beckhoff presentation, just to mention that Beckhoff develops this, I'm going to call a library, communication library called ADS. The ADS is the one that goes to the field device. So you may say, oh, can you talk to a TwinCAT that is communicating over Profibus? Well, for us, it is transparent. You're going to talk to the ADS. The ADS is the one that's going to go talk to the controller or the IOs and bring us whatever information we request for them. So this allows the communication to be really fast, because you're talking only memory to memory. Talk to ADS, we're going to always get the data there. Okay? So this slide here shows that the different architectures that you can have. So you can have on the same machine both Web Studio and the ADS running with TwinCAT runtime, so they can be on different machines, or they could be on the same machine. Like if you see here on the right side, you have both Web Studio and TwinCAT on the same computer, or you can have the development separated in the runtime on different computers. So this gives you an idea of how many different options you have. So basically what I want to say is you can run both on the same CPU, let's say on the same controller, or you can run Web Studio in one computer, TwinCAT on a different one. Even if you're talking about embedded systems or Windows CE, Beckhoff now they have Windows CE 7 as well. It's fine for us too, so 7, 6, whatever Windows CE version you're using, the driver is compatible with that because, again, we talk to the ADS. So let's start configuring a little bit the driver. So what do we need to do to communicate? We basically have to know where the PLC is, and for that we're going to use the network address for that PLC and which TwinCAT variables we're going to communicate with. So it all starts by knowing where the PLC is. And in order to do that, you're going to have access to the AMS net ID of that PLC. The AMS net ID, as you can see the description that I put here, that I copied from the system information file, is basically, this is the address of the local computer in the TwinCAT network, and it consists of 6 bytes and is represented in a point notation. So it looks like an IP address, but with 6 bytes instead of 4 only. Okay, so how do I get the TwinCAT 3? That's the address where the PLC is running. So with TwinCAT 3, you can get the AMSNet ID by right-click on the TwinCAT icon and select About TwinCAT. So I do have here a TwinCAT 3 running. So here's the icon. If I go here on About TwinCAT, it's going to go and get me the AMSNet ID when I'm running on TwinCAT 3. All right? So if you're communicating with a remote TwinCAT 3, you have first to create the route. All right? So on TwinCAT 3, you're going to go on System and select Choose Targets and search for Ethernet, and you're going to create the route. And I'm going to show here how we actually do that. If you're going to have TwinCAT in one computer and the runtime for Web Studio in a different computer, where you're going to have the Web Studio runtime, you should also install TwinCAT, only because it's going to install the ADS library. You don't have to install the runtime. You don't have to have a license for the runtime. Just install the engineering part or the ADS part only. That's pretty much what we need. And the other characteristic is that besides the AMSNet ID, since you can run multiple PLC instances on the same CPU using TwinCAT, you need to say, okay, which PLC am I going to communicate with? Okay, and you identify that by the port, the TCP/IP port number. On TwinCAT 3, you can configure that port number. So by default, it starts on 851. And we're going to keep that in our presentation here as the default. If you go back to TwinCAT 2, and a lot of people are still using TwinCAT 2 because it's a great stable software out there, again, we go back into trying to know how you can find the AMSNet ID information on TwinCAT 2. In that case, as you have the runtime here, you can select right-click and then go onto Properties. And on Properties, you're going to see the AMS router is going to show your AMSNet ID. So on my computer, it is 10.168.23.54.1.1. All right. Again, you have to create the route. But different than TwinCAT 3, what you're gonna go through the System Manager on TwinCAT 2. Okay, so on TwinCAT 2, we go here on the System Manager and we choose Target. And if we click on Search Ethernet and Broadcast Search, it's gonna list all the devices that are on my network. As you can see here, I have a bunch of TwinCAT devices on my network. You're going to list the AMSNet ID and the IP address where they are. So you must have this X here. Okay, so for instance, I cannot communicate with support PC2. Even though I know the AMSNet ID, I don't have the route created. Okay, so I can click on Add Route, enter user and password. So doing this, I will be able to communicate with this guy as soon as I see the X in here. Okay, so that's with TwinCAT 2. If I go with TwinCAT 3, I have that on this other machine here. I just have to go here on System, choose Target again. So as you can see, same window, same thing. Search Ethernet again, Broadcast Search. And I'm going to find all the TwinCAT that are on the network. All right, again, so I'm going to have the X here in order to communicate with those TwinCAT devices. All right, so and finally, TwinCAT 2 supports only 4, and only is a little bit ironic, but 4 PLC runtimes on the same system, on the same machine. Okay, and the ports back then, they were not configurable. So if you're going to talk to the first PLC, the TCP/IP port number is going to be 801, and then 811, 821, 831. All right, so using Web Studio, you can talk to all those guys as well. So the first thing to communicate with Web Studio and TwinCAT is knowing the MSNet ID and the target system that you want to communicate with. All right, so we're going to go to the next slide and show the first possibility of communication that you have between InduSoft and TwinCAT. So we're going to talk here about the tag integration. What is that? Let's say that you create your TwinCAT project, and then you can save and build your projects and link that TwinCAT symbol file to the Web Studio project. Okay, so here's what we're going to do. We're going to integrate with the TPY file that's generated by TwinCAT, and right now it's only available for TwinCAT 2. We are developing this same tag integration for TwinCAT 3 as well, so pretty soon we're going to have that, and discussing the pros and cons for that. Pro, as you guys are going to see, is very simple to configure that and start communicating right away with minimal configuration. The only con that I see with this is that you don't have much control of the communication. As soon as we import the tag, you're going to communicate, and by default, the communication rate is going to be 600 milliseconds. If you want to faster than that, there are a few things that you can do. You can bring down to a few milliseconds, but then it's not as trivial as just communicating with it. So let's go to a live demonstration of that. So I'm going to go here and start something from scratch. I'm going to create a project that's going to be TwinCAT tag integration. I'm going to make it as if I'm going to an embedded platform, and I'm going to put a resolution for embedded. So let's say 640 by 480. There you go. And so where I'm going to go? Under projects, I go into the communication window here, and I'm going to add a tag integration file. So which file am I going to communicate with? So I have here this TwinCAT project, the Machine Pro. Let me see. I have created this guy. I'm talking to the PLC, and I have a few tags here. So I'm going to go and build this. So the first thing I have to do is under Options and Symbol Configuration, I need to make sure that we have these two guys checked. Maybe we don't need both of them, but I always check. I know it doesn't hurt. And then Project, Rebuild All. When you do this, it is creating the symbol file. So we log on, and here we are communicating. So here on this TwinCAT project that I have saved, here under TwinCAT Samples First Steps, I'm going to find the symbol file as well. So I go back on Web Studio. I'm going to add a tag integration source. I'm going to give it the name, let's say TC, short for TwinCAT. So I'm going to enter the MSNet ID of the TwinCAT that I want to communicate with. All right? So which one am I going to communicate with? Let's see. Right now on my PC, I'm talking to this one here. There is 5.7.46.126.1.1. What is this guy actually? If I look here on the System Manager, this is actually one of my CE runtimes here. If I search the Ethernet again, it's going to show all the available TwinCAT. You're going to see that this one, 5.7.46.126, is actually a TwinCAT runtime on Windows CE 5. So I'm going to have TwinCAT running in one machine and Web Studio on a different machine, and that's going to work. You're going to see that it's as simple as if they were both on the same machine. Okay, so I go here on my Web Studio, and I'm going to enter this AMSNet ID. And I tell which runtime I'm going to communicate with. So I'm going to keep 801, and then I'm going to browse to find the symbol file that I put here under the TwinCAT Samples First Steps. So here is the machine TPY file. I click OK. So now I have connected my Web Studio project to that TwinCAT application. So I'm going to go here, create a screen. And I'm going to put an object that's going to link to the variables that are running on TwinCAT. So first thing I'm going to do, here I'm going to go and insert, for instance, one of our text objects. And I know they have a variable called count. So I'm going to show the variable of count. So I put a text, I put some pound signs. We have other objects like a text box or things like this that you can use. So I'm going to link the pound signs to a tag. So I open here my object properties. I click on this button here. So now I can see that I have on my tag list, I have also tags for the TwinCAT. So all these tags here, they are not on my project yet. You can see their colors slightly different, the color for the fonts. So I can go here, click on count, click OK. So I have just imported this tag. So let me see the communication happening. I'm gonna go here on put here a button just to exit the project. So during my runtime, I'm gonna save this screen. I'm gonna call this my main screen. All right, that will be my startup screen. And I'm going to start the communication. So here we are starting to establish the communication, and you can already see the value for the counter. Well, the counter that is actually running on Windows CE. This is the Windows CE device with that AMS net ID. So if I call here on the control panel the CX configuration, here it is, 5.7.46 for 126.1.1. That's the one that this TwinCAT is communicating with. So if I go online here, you can see the count is 5195, and that's what I have on Web Studio now, 5196. All right. So I'm having some communication issues here because my network is extremely busy right now. It's not dedicated. So if I go here on the output window, I can right-click, select settings, and see how my communication is going. So I select my checkbox field read commands, and I got a couple of timeouts, and then it goes OK again, and the communication is going on. All right. So you can see how simple it is. All the tags that were imported, they're going to be under global and shared tags database. So here's the tag that we have imported, count. Can I import more than one tag at a time? Yes, sure you can. All you have to do is to find a way to open the object finder, what we call here object finder. You can do that, for instance, directly on the database SPI. So you open the object finder, you can select, so if I hold the control key, I can select more than one variable. So I'm going to import, for instance, the timers. I have here the dev speed. I click on this button, import selected tags. Confirm. They were added. So if I look here on my tags list, now I have all the tags imported, including the tag that is time on delay. We create automatically the class for that as well. All right, and we are communicating with them as well. So if I grab those tags here and I put them on my database SPI, you can see that we are already communicating with them. Only the timer, I will need to put which, let's say, which member I'm communicating with. So let's say if I go here and choose the timer, I can pick the member. So let's say present time. And as you can see right now, it's blank. All right. So this is the tag integration. As you can see, it's very simple to configure and to start communicating. You can see the steps here, changing values constantly. So I could go here on my screen and also display steps. There you go. I'm going to save this. So I didn't even need to stop the application. It's already, everything is running. So here we go. We got the values. You can see steps updating every 600 milliseconds. Can it be faster than this? Yes. You have to change one parameter. When I talk about the main driver sheet, I'm going to go more in details with that parameter. But it's not as trivial. Like you're gonna need to open the app file and modify one parameter. App is the Web Studio application main file. Is an INI-like file. Okay. All right. So this covers the tag integration. Just keep in mind we only have that for TwinCAT 2 at this time. So now we're gonna talk about the drivers, the communication drivers. If I'm gonna go and configure the TwinCAT driver. So we already know that we have to have the AMS net ID and where to get that. And what else do I configure if instead of using the tag integration, I'm gonna go and manually configure the driver for communication, which has its advantages as well. So on TwinCAT, you can have both local variables that are gonna be inside the POU scope only, or global variables that are available for any part of the program for any POU. So pretty much what you have to do is you're going to associate the Web Studio tags to the variables by using the syntax that on the variables, on the address field, you're going to put, in the case of local variables, you're going to put the POU name dot variable name. For global variables, since they don't belong to a specific POU, you just put dot, and then the tag name, as you can see here on this screenshot, you have both what we call the main driver sheet and the standard driver sheet configuration. Okay? Station field, you put the AMS net ID, and on the address, on this case here, I have main.localvar. As you can see, I have a program called main, and I have local variables. Here I have this local var, or I have a structure, which is the time on delay. So I put here the main.localtimer dot whatever is my member. So I put here PT as present value, and I put here a global variable, the global bool. That, as you can see here, is the A bool test, is the second variable here on my list. All right? So that's the syntax for TwinCAT 2. So if I go here on TwinCAT 2, so I have Web Studio here. I'm going to stop, and I'm going to create a project to communicate with TwinCAT 2. Okay? Embedded. I'm going to put this with, let's say, a size 640 by 480 again. So I can download this to an embedded without any problems. So I go here on the count tasks, and I insert a driver I have on the list, the TwinCAT driver. So I add it to the project. So then I have the main driver sheet by default, and I can add standard driver sheets as I want. So configure the main driver sheet first. So what I'm going to do, I'm not tie it to the tag anymore like I was with the tag integration. So I have to say where my PLC is. Okay? So for this demo here, I'm going to communicate with a PLC that is running on this computer here. Actually, on this other computer here. All right? Where I have those variables constantly change the values, and I have this OPC simulate telling how to run that. So what is the MS net ID? Right-click, Properties. The MS net ID for this guy is 10.168.23.112. All right, so I'm going to go talk to 10.168.23.112.1.1 on the first runtime. Okay. All right. Which variables am I going to talk to? I look here on TwinCAT, and I have a variable called d_d_int test. So I can go on d_d_int test. Since that's a global variable, it starts with a dot. All right. So I'm going to put here my Web Studio tag would be, let's say, int test. And I can also configure the communication to a local variable. So I'm going to see what local variables I have there. So if I look here on my project, I go under main. So I only have one variable called I here. So if I log out, the only variable that I have is main.I. So I can go here and even create more variables if I want. But I'm going to keep this way because of something else that I want to demonstrate. So I can go here, put main.I. Okay, and that's where I'm going to go. same station. So I put here POU name dot the variable name. Okay, so I'm gonna save this. If I want to test the communication only, I can copy these guys to our database PI, and then start only the driver task if I want. So I can go here on tasks. I can start manually each one of my tasks. So I have here my driver runtime. I started, and my communication is already happening. So you can see the values. The I loops so fast that we can actually see it. Okay, so I can go here and put now my double link test to see the actual communication speed maybe on a screen. So I can go here, create a screen. I'm going to put again a text. That's going to be my double link test. And I'm going to be talking to the tag double linked that I have created, and that tag is talking to the PLC. I'm going to put here also a button to close the application. Here's my exit button. And I'm going to save that as my main screen. All right, so let's see how this communication happens during the runtime. So I'm going to call the runtime now. So you see, it is basically updating every 600 milliseconds. So if I right-click on my output window and select Insert Date Time, so my messages are going to start having a timestamp. So I can analyze, and you're going to see that that's pretty much what's happening here. You can see on this message here that the time between them is 632 milliseconds. So it's always going to be around 600 milliseconds, the communication rate. Can it be faster? Oh yes, it can be much, much faster. How? If I use, instead of the main driver sheet, if I use the standard driver sheet. So on this standard driver sheet, if, well, we're going to discuss later which one you should use, but if I configure the standard driver sheet, I can configure my trigger for reading whenever the tag that is here changes. I'm going to read. So I could put here, for instance, a tag called blink fast. Is a system tag that changes the value every 200 milliseconds. Or I have the field enable read when idle. Whenever I have a true value here, we're going to start reading as fast as possible. Okay, so if I put a tag here, let's say enable read. Whenever this tag is 1, I'm going to start reading. If this tag is 10, I'm going to start reading. It goes to 0, I stop reading. But read as fast as possible. If I just put 1 here, I'm going to read as fast as possible all the time. And for writing, I have a trigger that would write all the tags that are on the worksheet here, whenever this tag changes. And for enable write on tag change, whenever the tag that is here changes, I'm going to write only that specific tag. Whenever this field here is positive. So if I put again 1, whenever the tag changes, I'm going to write. Okay? Station. Here I put where is the PLC that I'm going to communicate with. So I'm going to enter here the AMS net ID of that PLC that I'm trying to communicate with. All right, AMS net ID and runtime number. And on the header, I specify that I'm going to communicate with the tag names. All right, so I'm going to put here the same tag that we have, these 2 tags, and they're going to go to the same addresses. So we follow the same syntax. So it would be, for the global variable, just dot d underscore the int test, and for the local one, would be POU name dot the variable name. I'm going to put here one more tag. That's going to be, I'm going to call it enable count. It's going to be a Boolean tag. And this I'm going to connect to a global variable here that we have on the TwinCAT project. If I go here to the global variables, global variables is this guy here called OPC underscore simulate. The way it works, if I stop it, it stops counting. So we can test it. If I enable it, it starts counting again. So I'm going to go here and talk to the .opc simulate. All right, I'm gonna save this guy. As soon as I save, you can see how fast the communication is happening now. If I pause for the group 1, which is this worksheet here, as you can see, sometimes I have even less than 30 milliseconds between messages. Sometimes a little bit over that, like here. I have almost 40 milliseconds, but that's pretty much what you're going to have. Here I have, again, less than 30 milliseconds. Okay? So, and it doesn't matter how many tags I have here, I'm going to always be between 30 and 40 milliseconds. If I see that on the screen now, check it out. Probably the WebEx cannot make justice for how fast we are communicating here. And it is bidirectional, so I'm going to go on my screen, and I'm going to put a checkbox that I'm going to link to the enable counter. All right, so I do this here, save. So when I uncheck this, it's going to stop counting. There you go. I check again, starts counting again. So when I do this, I'm sending to the PLC the command to stop counting. So I'm going to enable here, inputs. So I'm going to write to this tag double int test. So I'm going to write here, 789. When I look on TwinCAT, actually, it's going to be here. I have the value 789 that I have just written. I'm going to write a value to the tag. I'm going to write, for instance, 111. That's the value that I have on my D double int test. When I look on my Web Studio, that's what I have on Web Studio as well. All right, I change the value here. The value goes immediately to Web Studio. I change on Web Studio. It goes immediately to TwinCAT. All right, so I'm going to write here the OPC simulate. Now it's false. I'm going to write here goes to true, and start counting. You can see how fast this is communicating now. All right, so we did all that so far with TwinCAT 2, and we looked on the main driver sheet and on the standard driver sheet. So if we look on TwinCAT 3, it's very similar, with the difference that on TwinCAT 3, for the global variables, now you can have several folders of global variables. You have to put the name of those folders as well. So on the screenshot here, I have a main program with a couple of local variables, and I have a folder with global variables. Okay, and then I create it. So when I configure the driver, I have to put the folder name for the global variable. Like here, I have gvl.globalint. Here's my variable. Okay, and for the local, I go again and put the POU name dot the local variable name. All right, so here we have on this machine, I have here a TwinCAT 3 project. Okay, so I'm gonna open here my global variables. There you go. So we created this global int. You can see the values here are changing, and on the main CPU called main program, I'm basically, as you can see, just loading the values. So I'm gonna log out. That's the logic. I load the value of the local double int to itself, basically just incrementing. So these guys, they both gonna have the same value if they start together. If I write values to them, then of course they're gonna have different values. All right, so I have here the gvl.globalint and the local variable that the scope is only inside the main program. All right, so how do I communicate with them? Again, I need to know what is the MS net ID. You can see here is 10.168.23.164.1.1. The runtime number for this guys is going to be 512. In the PLC settings, here, 512, it's going to be 851. Okay, that's the port number. All right, so back online with the PLC. Again, I can see the values changing here. So I go on my Web Studio project, and I'm going to communicate with that PLC on the same project. I'm not even stopping. So I'm going to go here and put the MS net ID on the main driver sheet. I guess was 164, and 851. Okay, so if I look here, it says 164, that's correct. So here I have to put what's the variable name that I'm going to communicate with. So if I look on my variable names here, I have one called gvl.globalInt, okay, and the local double int. So gvl, the global, dot global int is going to talk to my variable that I'm going to call here global int tc3. That's for the TwinCAT 3. Just create the variable. And I'm going to talk to other variable there. There's the local that is going to be under main dot local double int. So I'm going to put here local double int TwinCAT 3. The integer tag. I'm going to save this, guys, and just save it. The worksheet is already communicating. I put these guys here on the text database. You can see them counting. All right, so I'm going to reset one of them. So now they're no longer synced because, I wrote a value to one of them. And you want to see how fast they are communicating. Also, okay, we have to put them on a standard driver sheet. So I'm going to make a standard driver sheet using this excellent resource called copy and paste. I'm going to copy the station. I'm going to enable here, read write. On the header, I'm going to put name again. The address is exactly the same syntax as the main driver sheet. Control C, Control V. I'm going to save this. And you're now talking to both TwinCAT 2 and 3. So I'm going to put this tag, global int, on this screen. Okay, and I'm going to put also the tag local, the int. All right, going to save my screen. And as we look at it, as you can see, it's pretty fast. Every 200 milliseconds we are communicating. All right, so as you can see, it's not that difficult to configure. If you have tag structures, you can put them on Web Studio. If you have nested classes, all type of things, arrays, they are all compatible. Whatever syntax you use on TwinCAT, you use the same syntax on Web Studio, and that's going to communicate. All right. So then we get to the point where I choose if I'm going to use the driver, if I'm going to use the main driver sheet or the standard driver sheet. We've seen that we can configure both. The pros of the main driver sheet is very simple to be configured. You don't have to worry about how many tags you're going to have per worksheet. And why do I say that? On the driver configuration, as you right-click and select Settings, you have this parameter called Max Block Size. That's going to be how many tags you're going to ask for TwinCAT on just one request. Okay, we put this optimal value here of 512, but it can be much more than that. But whatever value you put here, that's going to be the number of tags you can put on a standard driver sheet. And if you're using the main driver sheet, we're going to break into blocks of communications with a max of 512,000 tags on each request for the PLC. Okay, and you can, but to optimize the communication, the only thing you can configure is that you can scan always. So whenever you put always, you're going to be talking to that tag all the time. Screen only, so only when the tag appears on the screen. So you can put the always would be all your alarm tags, the tag that you're reading history, and screen would be the tags that you only want to see those tags when they are displayed on the screen. Okay, and we have also the option auto, where if the tag's on the screen, it's going to behave as screen. If it's as screen only, if the tag is being used on any scripting and any background task, we're going to act as always. All right. The cons for the main driver sheet is a fixed scan rate for everybody, for all the tags. And you have to put, on every single row, you're going to have to put the station field that you want to communicate with. It's a little bit difficult to identify when you have errors, which group is faulting, and you can write items only. You cannot write groups like using the standard driver sheet. You can write in just one shot all the parameters for one recipe, for instance. On main driver sheet, you can use only one of them. When you go to the standard driver sheet, you start with the pros. you can have total control of your communication. You can have tags on those fields for the read trigger, for the enable read when idle, and during your application you enable the communication or not to that specific group. Okay? You can read constantly or per demand, and constantly, as you can see, can be pretty fast. You can write entire group of variables using a read trigger. So that's very helpful when you're sending a bunch of parameters, very common when you're using recipes. And you have the feedback for each group on the fields that we have the read status and read completed. And you configure the station field only once. Okay, so you configure the station field there. The entire worksheet is going to talk to that specific station. The cons to it is a little bit less user-friendly than it is the main driver sheet. And you have to obey the block size on the standard driver sheet. So if you put more than 512,000 tags, we're going to give you a block size error. So you have to keep that in mind. But, you know, while you're doing the engineering, this is a simple thing to do. Only one station per worksheet. So in our case, I had to create 2 standard driver sheets because I'm talking to 2 different PLCs. Sorry about that, guys. I've been disconnected for the audio part. So continue where we stopped it. So I was talking about you can have only one register type per worksheet, and by register type is one type of header. So on TwinCAT, we're basically talking to tag names, so that's not a problem. But let's say you want to talk to the physical address, as we're going to see with the BC 9000, then you have to have a separated worksheet for this, okay? So depending on how you structure your project, you may end up having several worksheets. We have customers with, you know, thousands of driver worksheets. That sometimes makes the maintenance a little bit hard, you know. So let's talk about the other communication possibilities that you have for the integration between Beckhoff and InduSoft Web Studio. Just skipping one slide, I'm going to go back to that in just a little bit. The other possibility that you have with TwinCAT is to run in one of their non-Windows controllers. They have, for instance, the BC and BX 9000, for example. So when you're doing this, I have one computer here where we are doing that. It's actually not connected anymore. I'm going to connect now. And I'm going to close this one here. And I'm going to go to my TwinCAT here. Okay, so here we have on this address 10.168.23.40 the communication with ABC 9000. All right. So here we have some variables. So when I look here on the PLC, that's the one that we are communicating with here. Is the BC 9000 on the port number 800. All right. So I'm gonna go online. As you can see, all those variables, they have addresses. So %M. W10 or double word for the double int 100 or specific bits. So I configure a quick application here where I put the MSNet ID, the port number 800, a few tags, you know, and the physical address where they are. So I have here MW10, MD100. So when you're talking to BC or BX that they are non-Windows, you can talk to the variable names, but you can talk to the addresses. So I configure that. I can see the values for those tags here on the database PI. So if I go online with the PLC, those are the values that I have. I'm going to change the value on the PLC. So for the MW10, I'm going to put 222. I'm going to write to it. You can see already the value on Web Studio. Okay, I'm going to put here, let's say 2222. I'm going to write to it. And you have that on Web Studio as well. So the difference is that I can have the tag name on the IO address configuration. All the rest is pretty much the same. Okay, so if you're configuring standard driver sheets for this, you're going to have a standard driver sheet for the M's, a standard driver sheet for the I's, okay, one for the Q's, and so on and so forth. All right, so if I go here on my M's and I enable the communication, they're going to be pretty fast again. As you can see here on the right side. If I pause, we have again around 30 milliseconds for every communication. Again, because we're talking to the ADS, I'm not going directly to the PLC. I'm talking to the ADS, and the ADS is doing its magic, acquiring the data in the speed of light and just giving to me whenever I want it. All right? So this is the part that I'm talking about, the communication with the BC. So let me go back one slide here. Back, actually. So for the other communication possibilities, OPC UA. If you are familiar with OPC at all, you're probably familiar with the OPC Classic specification based on DCOM. Okay, so both InduSoft and Beckhoff, we do have products for OPC Classic. But the evolution of OPC brought it to be able to run outside Windows environment only, because DCOM is a Windows things only. So you may want to have your CPU with the OPC UA embedded on the CPU nowadays. So you have some computers, some PLCs out there that already have this option, and that's one thing that you have with Beckhoff as well. All right. So talking about OPC UA as a technology, is safer than DA, is very robust, and Beckhoff is so much into OPC UA that the president of the OPC Foundation in Europe is actually Mr. Stefan Holt from Beckhoff. Okay, so I do have here one of my computers, the 139, where I actually have configured an OPC UA server. So all you have to do is to download the OPC UA from Beckhoff's website. You see that? So you can download it from Beckhoff website, license it, and you have that for both TwinCAT 2 and TwinCAT 3. The only one that I have running here right now is actually the OPC server for this TwinCAT 2 computer here. So pretty much what you have to do is to configure. When you install TwinCAT, you're going to have a folder called OPC. You go to UA, and you configure this XML file here. And that's again for TwinCAT 2. On this XML file, you're going to have all the information that you may need. For instance, what will be the URL? What are the supported security policies? Okay, so none on OPC UA. You can encrypt if you want. You can sign and encrypt. You may require certificates for the communication, so it's way more secure than the regular OPC DA communication. And you enable which PLC you're going to communicate with, so you can go and edit this XML file to have the OPC UA configuration. All right. So I do have here the service, the TwinCAT OPC UA server running. Not sure if that's still running because I've been running for a while here. So if I go here back on my Web Studio, I'm going to stop this guy, and I'm going to configure on the same project an OPC UA connection to that PLC. So the first thing I do, I create a connection. So I'm going to call here, my connection is going to be called TwinCAT. I'm going to connect that to that PLC, which is under WinXP-OPC. Let me try that. So I ran the discovery, and I found that OPC server here. Okay? If you had OPC before, that would be equivalent to the OPC enum. I'm going to test the connection. There we go. I'm connected to the OPC server of that Windows C device, to that TwinCAT device. So I'm going to go insert a worksheet here, select my connection, and now I can start associating my tags, my Web Studio tags too. As you can see, I'm browsing here, and I see all the variables that are in there. So I'm going to have here this guy called FUINTTest. I even have the values, the type, everything. So I'm going to grab another one here. Let's say the EUFINTTest. Okay, so I'm going to associate with the FTest. And I'll call here my ETest. I'm going to even go further and bring a string. So, all right. So here I'm associating my Web Studio tags to those OPC UA items. I save this OPC UA worksheet, so now I can run the OPC UA client runtime, and I'm going to be communicating through OPC UA as well. So if I put those tags here on my text database, you can see the communication already happening through OPC UA now. So I can put those tags on my screen. So I'm going to put here, for instance, the F test. And I'm going to put here also the string test. Oh, actually, the string test I created as integer. I went too fast. So let me change that to put that as a string. And back to my screen here. I'm going to remove the input. I'm going to put it as auto size. I save my screen. And I'm going to call the runtime to show everything. So now I have the driver. And everything happening. Maybe I don't have a string value there, but you see the driver, and you see the communication also through OPC UA. Okay, can this communication be faster? Yes, it can be faster, because on OPC UA, you can configure here on advanced the sampling rate, and you can configure the publish rate. So I'm going to change my publish rate here to 10 milliseconds. Okay, so now I have here for my runtime. As you can see, we're talking every 10 milliseconds to the PLC through OPC UA. Right? As you can see, it was very simple to configure that. All you have to do is on your TwinCAT, you install the OPC UA server, you install the license, and when you're configuring the variables, if I go here and I'm going to go offline, you have to put this comment on the variables that you want to serve on OPC UA. Alright? Once you have that, here you have some like constant, double int, stick, bit, or things like that. If you go back on Web Studio, we can browse through all those variables. They're all here on the list, including the OPC simulate, including local variables, including local variables from a program called arrays. All right, so that's the OPC UA option. Finally, on some devices, you don't even have Ethernet. So you may want to communicate through a serial communication to to one of those BCs, So you can install libraries on your TwinCAT program that speak, for instance, Modbus serial, Modbus TCP/IP, and we can communicate through those using our Modbus drivers as well. That's how flexible TwinCAT is. And they have not only Modbus, they have BACnet, they have IC 870, and we have drivers for all that. Okay? So depending on your installation, you may need to use one of those other protocols, and we're going to have the drivers for that. So finally, we're going to go now and visit the troubleshooting section of this presentation. So everything so far worked fine, right? So what are the most common problems that you have? So you have to keep in mind that we don't talk, the TwinCAT driver, the TWCAT driver, doesn't talk directly to the TwinCAT runtime. We talk to the ADS. The ADS is the one that goes to the PLC runtime, okay? So that communication between us and the ADS always happens. So sometimes you may have to test what is happening between the ADS and the runtime if you're having a faulty communication. So the most common error that we have is because when you're configuring the driver, you have to type tag names. Sometimes you may mistype a tag. So for instance, I have here a tag called main local double int, or I can even go here on my, let me go to my TwinCAT here. Sorry about that. I'm trying to find the TwinCAT tree. There you go. There you go. You get 3, so I'm gonna go offline. And I'm gonna add one more variable on my global here. So I'm gonna put here test var with a double link. Okay. I'm gonna put this variable here. I'm gonna rebuild my solution. And I'm gonna download to the PLC. Download. And I'm gonna run. There you go. I'm gonna enter a value on it. I'm gonna write. Not equal to 7 anymore. There you go. I have the value written here. Okay, so I'm gonna talk. Let's say I have this variable called test var. So I'm gonna go on my Web Studio here. And as you can see, the communication is still happening. I changed the PLC program, and we're still communicating. So I have test var 1 by accident. If I save this, you're gonna see that this tag here has a bad quality. And if you look on the output window, if you enable the protocol analyzer option, it's going to show which tag was not found. Okay, so this variable called main.testvar1 was not found. Oh, I need to go back, look on my driver sheets, and fix it. I save it. And let me pause. The test var is not there still, and I believe it's because I guess I have to use it somewhere. So I'm gonna go here on my main program. I'm not using that variable, so I'm gonna put here dot test var. I'm gonna load it on itself, so it's a very dumb program here. Okay, I'm gonna rebuild it all. And I do have one error. So I'm not sure what I'm doing wrong here. Maybe I have to save this one first. I have to save main, and then I build. Oh, I'm missing this. I'm programming with the Visual Basic way of programming. So I'm gonna do this again, and I'm gonna rebuild everything. Okay, we are good now. I'm gonna download this to the PLC. And I'm gonna tell it to run. So I'm running, and I'm gonna go here on my Web Studio. Because not main, it's actually GVL. That's the problem. Now we're good. So I'm gonna write a value to it. Or I'm gonna put here 777. When I look on my TwinCAT, I do have the value that I have written to it. Okay, if I look on the variables, I'm gonna prepare a value here to write. Let's say 888, and I'm gonna write to it. There you go. When I look on Web Studio, there you go. I have the new value here. All right. So this was simple to be fixed because what? Because we have here on the output window showing which variable is wrong on the communication. All right. So sometimes again, the communication between Web Studio and the ADS always happens because we are on the same machine. Okay. The other common problem is that you may have not created the route to that PLC that you're trying to communicate with when you're not on the same computer. Okay. So to create the route on TwinCAT 2, you're gonna go on the System Manager, as we talked before. So go on System Manager here, choose Target, search Ethernet, broadcast search. Only the ones that I have the X on the connected are the ones that are going to be able to communicate. Okay, so I can talk to TwinCAT 3, but I cannot talk to InduSoft Joel, for instance. That communication is going to fail. So go back here and see if you actually have the route. All right, so sometimes you have the routes, but the communication is failing anyway. So you may want to use a tool to validate the communication between ADS and the runtime. So when you install TwinCAT, you can go on this folder here, TwinCAT, you go to the ADS API, and you have the TwinCAT ADS DLL here. And you have this little program here called the ADS test. If this guy works, the driver is going to work as well. If this guy fails, the driver is going to fail, because we are both using the ADS. Doing this, you can take away your driver configuration from the equation. You can try to troubleshoot on the problem that you're having on the network between your computer and the TwinCAT runtime. So first thing you do, you click on ADS port open, you got a confirmation, and you go to the test button. So here you're going to see the list of all the registered routing, so all the runtime that you can talk to. So I'm going to put here, for instance, the one that you're talking to is the 164. Okay, the port number is 851, and I'm going to talk by variable name. In that case, I have to put a valid variable name. So I have my gvl.testvar. I'm going to start the communication. All right, it works. So if this guy works, the driver is going to work as well. If by any chance I had this wrong, the variable name here, I'm going to put, for instance, main.testvar that I was trying. I'm going to start. See, it fails. If it fails here, it's going to fail on Web Studio. All right, so doing this, you can troubleshoot the connection between the ADS and the runtime. If this guy fails, we're going to fail. If this guy works, the driver is going to work as well, because we are basically sharing the same library. All right? So I'm going to open now for the Q&A sessions. You guys are going to see that you can send your questions either through the chat chart or the Q&A board. I'm going to read the questions. Depending on the questions, I may read the answer loud for everybody, or I may respond it privately. I just would like you guys to keep the questions within this scope. There is the connection between Web Studio and Beckhoff runtimes. If you have any questions outside that scope, we'll be more than happy to answer, but not on this webinar. You can send us an email. I'm going to show, here are the contact information. Okay, you can send an email to us. These are the 3 mails for the 3 different offices that we have, and we'll be more than happy to answer. And right now, you can send your questions for using the Q&A board or the chat. So I got a good question here. I'm going to read. Which communication would we recommend? Tag integration, the driver, or the OPC? To be honest with you guys, the answer is kind of, it depends, you know, and I'm going to explain why it depends. The tag integration is very simple to be configured. So in some projects, I would definitely use the tag integration, knowing that the communication rate is going to be the same for all the tags. So let's say that you have a touchscreen panel for a machine. You're going to communicate with a couple hundred tags. Yeah, I would use the tag integration. You know, it's very simple. I'm going to always have the TPY file updated because it gets updated automatically. I'm going to give an example here. So I'm going to go and create a new variable here on my TwinCAT. So right now, if I look, let me stop my project here. I'm going to open again the tag integration project that we have created. So I can see here the tags that we currently have. Okay, so I'm gonna go ahead and create a new tag here. And I'm gonna call that's gonna be a real type of tag. Okay, so as I rebuild this, the symbol file is regenerated. So if I go on Web Studio now, I can refresh the devices. I got the new variable here, the new var tag. Okay, I'm going to import this guy. So I have imported this tag. It's already on my tags database. So if I look here, on share tags, it's on my tags database. What if I rename this tag on the PLC? If I rename, it's the same for me as if you have deleted that. So if I go on the PLC here, instead of new var tag, I put old var tag. I save this. I rebuild this. If I go back on Web Studio and I open and I try to refresh, well, it's already here. And we are showing that the new var tag doesn't exist anymore. Okay, so I have this option to replace by this tag here. And we have replaced. If I have used that anywhere on the application, we would have replaced the new by the var tag. All right, so as you can see, it's very reliable. The tag integration is very simple to configure. But depending on your project, you may want to have full control of when you send a recipe, when you're actually communicating to certain devices and not to others. With the tag integration, you cannot disable the communication. We are communicating all the time. So in that case, I would rather use the driver. And which option of the driver? Usually, I would use the standard driver sheets because I want to have full control of my communication, even if it takes a little bit longer for me to configure that. All right? And when would I use OPC in that case, in that question? When would I rather use OPC instead of the driver? There are some situations that you may want to have several HMIs talking to the same PLC. Okay? You're going to be bombarding the PLC with data. If you have an OPC server on the PLC can focus on running, and the OPC server is going to focus on the communication as well. That's one option. Okay? And if you want to have more security than what can be offered in the communication between InduSoft and the ADS, you can use the OPC UA as well. And you also may know now that OPC UA is not only on the HMI and the PLC part. TwinCAT can also be an OPC UA client. And you have, for example, OPC UA clients for SAP. So you can have directly your SAP or your enterprise software talking to the PLC, sending purchase orders or getting status from the PLC, not even passing through us, let's say through the HMI that used to be the bridge to that. So OPC UA is a very powerful technology. So if you want to use that all over the board, all across the board, you can use that. So you can use InduSoft for the OPC UA as well. Okay? All right, so let me read another question here. So I got a good question here that I'm going to read for everybody. How does the tag integration handle arrays, structures, and can variables on a custom structure be linked to a tag of a class type? So these are two questions. First, how do we handle arrays? The way we handle arrays on the tag integration is this. Let me, on the tag integration, let me create a variable there that is an array. So I'm going to create here my array tag, and that's going to be an array from 0 to 10 of double int. I missed that, and here is dot dot. Okay, so I'm gonna rebuild all. There we go. So here I have now my array tag. If I go on my Web Studio now, and I'm gonna have, as I refresh the device, my array tag here. Okay, so I select this guy, I pick the index, let's say my tag 4, I click OK. I have created a tag here with the position 10, so we imported everything. Okay, so I do have a custom structure here that we have created that even has members that are nested classes. Is this tag here called myStructTest, which have a type myStructure here. Okay, so I go on Web Studio. I'm going to import, let's say, the member M2. So the way we do that, as you can see, we don't create the class on Web Studio. We don't do that for custom types or for how we call here the data types. Okay, but let's say that you're gonna import the fourth member, that is a tone timer on delay. If I'm gonna import that, that guy is gonna come as, let's say I'm gonna put PT here. I import this. Okay, so the whole M4 came because it's actually an existing class. So for the predefined types, like the timer on delay, timer off delay, we can use we can use this option. We can import and create the class automatically. Okay, with array multidimensional, let's say I'm gonna go here on my TwinCAT. I'm gonna create another array. Gonna be an array. Gonna be so I'm gonna save this and publish. Okay, so in that case, this tag another array, it comes here. As I show the way it is on the PLC, but when I import the tag, we put underscore for the first dimension, and we create an array with the second dimension size. Okay, so I click OK here. That's the only one that I have imported. All right, and that's because right now on Web Studio we don't support multi-dimensional arrays, and we don't support nested classes. We are working on that, but right now this is incompatible with the capabilities that you have on the TwinCAT when you're creating the tags. Okay. So I got a question here. You said that there's only one register type per driver sheet. What would be the register type? When I talk specifically about TwinCAT, would be this. On my driver here, I'm talking. Let me stop this. Let me go to this other project here. So this standard driver sheet, I'm talking always using variable names. If I want to talk using the variable address, for instance, %m, to go to the 10.168.23.40.1.1 colon 800. So I go to %m. I can only have %m here. So I put here 10 words. Or I'm gonna go to the D100 and see this as double int. So this will be my M10. This will be my M100. And I'm gonna talk to these guys as fast as I can. So I cannot here also talk to the variable names. Okay? So names here, %m here, or if I'm gonna talk this also to the same PLC but to the outputs, I have to put %q. Okay? I'm not sure that that's going to work because I'm not routed. Let me see. Yeah, I'm talking to them as well. That's very interesting. We're talking also to the TwinCAT I/O that is going directly on the BC 9000 that we have here. Okay, so that's what I meant by register type. Okay, why are function block parameters not accessible on TwinCAT 3? Again, whenever you have something that doesn't look right on our driver, you go back and you use this guy here to test. Okay, you can open the port, test, and here you put how the parameter syntax is. If this guy fails, that means that the ADS may not support that. If this guy works, the driver is going to work as well. Okay, so the question is, why function block parameters are not accessible to TwinCAT 3? That would be more a question that we would ask to Beckhoff if there is any special configuration. It's not a limitation on the driver. The driver is going to send whatever syntax I have to send for the ADS. Okay? So I highly recommend whenever you see something weird, go and test using the test program here. That's going to be under the ADS API, TC ADS DLL. All right, I don't have any other questions right now, so last chance, guys. I know we've been way over 1 hour. That was supposed to be the webinar. We are now with 1 hour and 43 minutes. So since now, I really appreciate what you guys are doing here. You know, staying that long. Thanks for that. So let me see. So the question again would be interesting here to see. I don't know if Rich, are you still there, Rich?
Yes, I'm still here.
Okay, I'm not sure if you can answer that. The question that I have from the customer here, you may probably see it on the Q&A chart, the last question. He's asking that the function blocks works with TwinCAT 2 and should work with TwinCAT 3. Probably, according to him, our tech support guys said that. I'm not sure we have the expertise to answer that as precise as you guys would answer. So I guess my question is, do you know if through ADS we can access function block parameters?
If they are declared, yeah, there is something different there in TwinCAT 3. I would have to look at the specifics on that.
Okay.
I guess I don't see the list on the question myself, but that's certainly something we can get answered. So. Right.
So what I recommend you that is asking this question, you know, let's get in touch with Beckhoff. Those guys will be able to answer you that and see how you're configuring it and help you to get the optimized configuration for that. Okay. So I got a question here. What happens with the tag integration if the TwinCAT variable name changes? That's a very good question. So let me stop here. And I'm going to go on the tag integration project that we have created. And I'm going to make that happen. So here I have configured my project to talk to this machine TPY file here. Okay, so I'm going to open that project. Here it is. And I'm going to go and change. Actually, I'm going to go and add one more variable here. I'm going to call this new var. That's a double int. I save this, and I'm going to rebuild all. So I have the new var here. So on my Web Studio, now, using the tag integration, so if I'm going to go, let's say, on my screen here, or even on the database file, so I'm going to put here, on my screen, a new field that I'm going to associate with a tag. That's data link. So here, you're going to find my new variable here. So I'm going to import it. All right, so I have imported to this field here. I save it. Then, I'm going to go on my TwinCAT, I'm going to change that variable name. Too much stuff open. So, instead of new var, now it became my old variable. Okay, I save, and I'm going to rebuild all. So that file has changed now. So if I try to open here now, see, it shows that a variable was changed on TwinCAT. So the new var doesn't exist anymore. If I want to replace that with one of the existing variables, or if I just want to delete that. Okay, so I don't know that it was replaced. I just know that it doesn't exist anymore because, you may not just replace, you may just delete that. Okay, so I can choose here and delete that variable. So I can go ahead now and select a new variable for it. So here's my old var now. Okay. So I'm just reading other questions here. So I got a question here. I'm going to read the question, it's very good. What is the load on the system from InduSoft CE? For example, if you have a small display with, let's say, 533 megahertz. So here's the thing. When you have a device that's going to run both the control and the HMI, if you're going to run that on an ARM, you may consider having a small application. Okay, and by small application, I mean a small number of screens, a small number of tags, and by small, let's say 500 tags. You shouldn't consider having thousands of tags on that case. Okay, on a 1,000, I mean even 2,000 tags on the Windows CE with 50 screens on the ARM processor, then you're really pushing it to the extreme. So if you're going for any ARM runtime, you can run InduSoft, you can run TwinCAT, but keep in mind that you should do a small application, mostly with native objects. Don't care that much about bitmaps. They are very intensive on the display processing, and then you're gonna be fine. So the smaller the device, the smaller the processor, the smaller the application should be as well. Okay. So I got a question why we are having communication errors sometimes detected on the output window. Well, we send a message for the ADS. If, in my case here, I have a very busy network because this is not a device network. This is my corporate network that I'm talking to. All the TwinCATs, the ADS is trying to talk as fast as possible, but we are also exchanging mails. We are also downloading and uploading things. Today is a very busy day here in the company. So we are in the same network for everything. So the network is actually causing the errors in my case here. Okay, and on my Windows CE here is actually a even worse network. I'm going through a couple of routers to get to that Windows CE device. So that's why I'm having communication errors in my case here. They're basically timeouts, and then the communication is restored and keeps going. So for the TwinCAT PLC software, which version am I using? On this computer here, I'm using TwinCAT 2.whatever, 2.x or something like this. Let me see here. This one is 2.11 and a build number. And on this other machine here, I'm running TwinCAT 3. Not on this one. Actually, on this one here, I'm running TwinCAT 3. As you can see, it is inside the Visual Studio shell. Okay, and the interface is all different. Everything is new and fresh. It's an amazing software. It's not because Beckhoff are our friends. I really like their stuff. Okay. So I got a question here, very interesting. Is the communication between two InduSoft sessions via TCP/IP worksheet faster than configuring a driver sheet to access directly the tag? I believe you may be saying that on the PLC. So the way our TCP/IP communication, by TCP/IP communication, he's probably saying our task here, TCP/IP, where I can insert a worksheet and put here an IP address from another InduSoft application. And here I'm going to have my local tags and my remote tags from the remote application that I put the IP address here. Okay, this communication you can configure under here communications, how often we're going to communicate. By default, 100 milliseconds. Okay? And, you can change to 10 milliseconds, or actually that's the lowest you're going to actually get. That would be 10 milliseconds. So this is pretty fast. You may consider using that if you don't want to keep bombarding your PLC with messages. Let's say that you're going to have 10 web studios talking to the same PLC. That may be a little too much both on the network and on the PLC. So you could have just one web studio station talking to the PLC with the driver and exporting the tags using the TCP/IP task. The communication is going to be pretty fast as well, because this is the same task that we use on the viewer module. So whenever a tag changes on the viewer, we send to the server project, and from the server it goes to the PLC. So that would be as fast as the viewer. So the answer to your case is which one is faster? They're both pretty fast, depending on how you optimize the communication. To talk to the PLC, the fastest that you can and I can suggest would be on this case here on the drivers, to use one on enable read when idle. Okay. So I got a question with the tag integration with classes. And the tag integration with classes, we got here an example. How does that work? Well, when you create a structure on the PLC, so I go here on my PLC program, and I do have a tag that uses the timer on delay. Okay, so that's a structure from Beckhoff. Or I can create my own structures here, so I can go ahead and create a data type here. I'm going to put here my type. And my struct here, I'm going to have M1 is going to be a double int. My M2 is going to be an int. My M3 is going to be bool. So I have created a structure called my type here. And I'm going to save that. And I'm going to create here M4, that is a struct inside a struct. So it's going to be a timer on delay, so nested structures. I save that. So I'm going to go here and create a global variable that I'm going to call my struct test. And the type is going to be my type. Okay? So I'm going to go on my project. I'm going to rebuild all. So I just rebuilt everything. So if I go on my tag integration here now and try to connect to that file, so I do have here my struct test showing here. So I show as a separated folder, and I do have the variables here. So I can import, for instance, my member M1. So I just imported. When I look on my shared tags database, here's my tag M1, but that's just an integer. I didn't import the whole structure. Okay? So if I go here and import, otherwise, the tag count would be huge. That's the main reason why we don't import the whole structure. But I can import the member for instance. I look here on the tags database, and that's from the class ton. So if I go here and I put this guy on the screen, I can put on the M4 and pick the member, let's say, PT. So now I'm communicating with the PT. Okay, so I create this guy as with the structure ton. All the other ones, they're going to be whatever type they are. All right? So I got a question, if I'm using a simulator implemented with TwinCAT software to connect the tags. No, actually, TwinCAT doesn't, I don't have to have the simulator, because as I install TwinCAT, I have the runtime everywhere. So what I'm doing on this computer here specifically, I'm talking to the runtime that is running on Windows CE, on this Windows CE device here. Okay, so this Windows CE runtime here has the IP 84. Let me see if I look on the about, if that shows my, so that's just the about information. As you can see, my network here is not as fast as we want to the Windows CE device. So if I go on the control panel, CX configuration, so here I have the MS Net ID, 5.7.46.126.1.1. That's what I'm running on this PLC here. Okay, so that's actually a CX PLC. I was just holding one here. So if you look on the slides, it looks very much like one of our slides here. Okay, so it looks very much like this one here. That's the one that I'm talking to. Okay, so that was the question if I was using a simulator. But no, I'm using no simulator. Okay, I got some questions here on the chat. So I got a question here, the difference between driver sheet running, enable read when idle, or editing the update through the app file. So the question is, if there's a difference between updating the driver sheet on the runtime or editing the app file with that parameter that I look on the help file. So the driver worksheet on the enable read when idle, let me go here. So that's a good question, but it's more structural about the product. So comparing the main driver sheet to the standard driver sheet. On the standard driver sheet, the enable read when idle, what this idle means? The idle means that I'm not writing anything using tag change, writing anything using the right trigger, and I don't have a read trigger happening. So when the read trigger happens, this has a higher priority than all the other worksheets that are enable read when idle. So let's say that you have 10 worksheets with enable read when idle, and one you trigger. You're going to finish whatever communication is happening and execute the read trigger. Okay? The main driver sheet is basically behind the on the backstage. It's basically creating virtual worksheets like this with read trigger of our tag blink slow. This tag blink slow changes every 600 milliseconds. So whenever this tag changes, we're going to read everything. So the difference between using the trigger and the idle is that whenever you use the trigger, you have a higher priority on that communication. So if you have too many tags on the main driver sheet using the trigger, and it goes over 600 milliseconds to read everybody, then the idle will never happen. Okay? Because the driver will never be idle. Okay? So a little bit of troubleshooting here. I got a question when someone's starting the system, the tags are not always updated between PLC and the InduSoft. So the first communication between InduSoft and the driver, we send a message, we exchange some information with the PLC where I tell the name of all the tags that I want to communicate, and the PLC returns to me pointers or IDs to those tags. And after that, we only talk for those IDs. That's why the communication is fast. So the first communication, when you have, let's say, 5,000 tags, the first time you're going to communicate is going to take a while because you're creating that list. Once that list is created, then the communication is going to go as fast, as you can imagine. So the first communication takes a while. You just have to wait a little bit, and then it's going to go fast. Is there a way to update the whole driver sheet after boot up? That's an interesting question, to update the whole driver sheet after booting up. And that would mean probably creating the driver sheets on the fly or something like this. Well, you can have tags For instance, on the station fields, it doesn't have to be hard-coded, so I could put a tag in here between curly brackets and then change the value of this tag whenever I want. So that could be on the boot up, so you don't have to have a hard-coded value there. But recreating the driver sheet, that's a little bit more advanced. Let's say we have a format very similar to our version 6.1 was, where all the files were text-based, so it would be just a matter of opening and seeing the format of that file, and then you would use some functions like a file write or a report functions to create a text file. Once the file is on that format, our runtime understands as well, but it's not as trivial as configuring the driver sheet like this. Okay. So I have a question here asking about the OPC UA configuration. So I do have here, I guess, is this computer here? Not quite. So let me log out. So pretty much what you have to do is this. On the TwinCAT side, you're going to have to download and install the OPC UA server. Okay? So you go here. As you install, and you're going to have the OPC folder and the subfolder UA. You have a license for it. Okay? And then there are some OPC configurations you do. That's TwinCAT 2. So I'm going to open this with, actually, let me just open on the browser first. On the XML, you do some configurations of this OPC server. So it goes, for instance, if you know about OPC UA, you have to have the URL of where the server is, okay? And then here you configure also the possible security policies. So the security policy can be no security policy, or you can have the security policy with encryption, basic 128, and then you're going to have non-signed, sign and encrypt, or I could have also user and password, for instance. And where the OPC UA is running, it can go remotely or it can go locally. So here shows the runtime. You're going to go on the 801, on the PLC1, and you're going to connect to the symbol file that is on the boot project. So by default, for the first PLC, it's going to be current PLC_1.cpy. Okay? And on the default configuration, it comes with 2 PLCs, but I put it disabled on the second PLC to 0. Communication very similar because I don't have 2 PLCs running on this device. So you can open and edit this XML file here. Okay? And then you're going to run the OPC UA server. Okay? So it's a process that's going to be running here. As you can see, it's running here. All right? So on the InduSoft side, what you would do, actually I have 2 running. What you would do is you would enter the URL that is configured here and the port number. So it would be this, opc.tcp : and then the node name, so it would be the computer name, colon 4840. So if I go to the Web Studio application here, I go on OPC UA, I create a connection. So let's say TwinCAT here, and I enter the endpoint, the URL, opc.tcp : / that computer is my winxp.opc, and the port number 4840. Okay? Or if the discovery is working, I can put here OPC and load the servers list. You would find all the UA servers that are available in there, which in my case here, the discovery is not working. And after I configure the endpoint, if I try to connect to it, it's actually complaining about the security policy, but it's not this error exactly. Basically, I cannot demonstrate the actual communication here with the OPC UA, this morning my machine stopped working and I couldn't troubleshoot that in time for the webinar. But that's the basic configuration. Once you have the connection created, you give a name to it, you have the endpoint, test connection. You're good. You would go and create OPC worksheets, set here the connection, and then you can browse to the items that are configured on the OPC UA server and associate them to our tags. That's how, technically speaking, the communication would happen. Okay? I'm sure that the TwinCAT people would be able to help you guys configure the UA server much better than I would do on their end. But once the UA server is running, that's pretty much what you do. You create a connection, okay? Give a name to the connection, select the connection on your worksheet, right-click, browse. It's going to fail, as you can see. And then you associate the item that you browse to the items here, to the Web Studio tags here. Okay? I'm really sorry I cannot demonstrate that, but that's the way you have to configure that. It's as simple as that. All right, so we are almost 2 hours now, and I don't see any other questions. So actually, I do see a couple of questions here, but they're not exactly related to the integration between InduSoft and TwinCAT. All right, so last chance. So I got a question here that asks this. I want to update my InduSoft software already integrated with Beckhoff. Okay? So you update your Web Studio, is gonna keep the tag integration with Beckhoff the same way as it was. If it was a driver, it's gonna work the same way. If it's the tag integration, it's gonna keep working. So you can upgrade from any version. We have the Beckhoff tag integration since our version 7, one of the source specs. So you can update that. That won't be a problem. Okay. So if you're using the tag import wizard, that's a different thing because once we import, the tags are there. So they're going to be on the driver sheet, they're going to be on the tags database. But if you use the tag integration, we're going to keep integrated the same way as it was, as long as the file, the CPY file is still there. Okay? So I got a question here on how to host the InduSoft Thin client on a Windows CE Beckhoff. From Beckhoff. So if you want to have a thin client there, the easiest way for you to host anything there is this. You don't even have to have a license for that. You just copy the CE server program to your Beckhoff device. So it's this guy here, remote agent. Okay, you run it, and from your Web Studio station, you connect to it. So here's the IP84. So I go here. 10.68.33.84. You connect to it. Okay, we are connected. And you run the install system files. Doing this, we can install all the files, all the runtime files, but we will also register everything that you need for having a thin client. Doesn't matter if it's a web thin client or our secure viewer there. All the files are going to be there. After you run install system files, you can even delete the DRV folder that we installed there. Keep only the bin folder. That's the easiest way that you have to have the Beckhoff device as a web thin client or as a secure viewer. Just run install system files. Install everything you need. Okay? That's the question on how to have a web thin client on the Beckhoff device. Copy the CE server file there, run it, install system files here. Where's the CE server? Web Studio installation. You're going to have the read this folder. So if I go under this function here, I have our product path. So if I go to the Web Studio solution, you're going to go under Resist, and then WinCE 5.0, and I'm going to have all the platforms, whatever platform you have. Under the bin folder, you're going to find the cserver.exe. That's the one that you're looking for. Copy this file to your Beckhoff device, run it, and follow the procedure that I just did. You're going to install everything, both the runtime or anything you're going to need there. Okay? So the question is there a way to import variables from Beckhoff with a two-dimensional array? Basically, no, because you can't. We don't have multiple dimensions. We import the variables, of course, but we don't create them in our tag database as two-dimensional arrays. You're going to create multiple tags with one dimension. Okay? All right. So we are 7 minutes about to go to 2 hours webinar. I don't have any other specific question here, so I just want to thank all of you for participating on this webinar. So where's my presentation here? If you have questions, you can here have our contact information, so you can send us emails for the different countries that we are here, and you have our phone numbers. You can call anytime. If it's a pre-sale call, we're gonna talk to you about all the options that you have on the product. If you're already familiar with the product and you have technical questions, our highly regarded tech support team is going to be happy to help you. Okay? So I would like to thank again Rich for joining us for this webinar, and thank each one of you guys that stayed either 5 minutes or during the whole time on this webinar. It was really good. Thank you all. And you're going to receive a brief survey. If you fill that survey, you're going to get one of our T-shirts from the webinar series. Okay? So I hope you guys enjoyed this as much as I did, and I'm looking forward to seeing you guys on the next webinar. Thank you all. Take care. Bye.